Hi dear students, once again I welcome you in my channel Mathematics Helper. I hope you like my videos. If you like my videos, please press the subscribe button and the bell icon for latest notifications. Let's start our next exercise 6.2, which is based on 2-3 results. So I marked all these results on the board. You just see, try to understand what I am going to explain here. That is, very first one, monotonic function. When we use a name monotonic for a function. Function means a statement given in a variable. So monotonic function is a function, okay? We are writing here a function is said to be monotonic in an interval. There will be an interval. Interval means a part of real numbers, means some gap of two numbers will be provided. So there will be an interval, for example, like this, closed interval AB or open interval AB. AB means some numbers A and B. So if it is either increasing or decreasing in the given interval, means if it shows it is increasing or if it shows it is decreasing in that particular interval, in that case we can give a new name to this function, that is called monotonic function. Now, what are increasing and decreasing functions? For that, you have to remember these results given. First one, for increasing function. When we say a function is increasing, a function fx is said to be an increasing function in AB, in open interval. This interval is open. Open means A and B are not included. All the other numbers of number 9, suppose A and B are these two, they are not included. All other numbers in between are included. So a function fx is said to be an increasing function in open interval AB if we choose x1 less than x2. What are they, x1 and x2? They are members from this interval AB, means x1, x2, they lie in this interval. And if x1 is less than x2, means first number x1 is less than second number. It implies when you put these numbers one by one in the statement of fx and get some answers, and they will also follow the same type of inequality, means f at x1 less than or equal to f at x2, then in that case we will say our function is increasing. Now there is another method. You can take help from derivatives also. I know you are familiar with derivatives now. When we say a function is increasing, fx is increasing in open interval if for all x belongs to the open interval, means for all the points which are members of this open interval, derivative gives answer greater than 0, means f dash x greater than 0. Now think about its opposite. Opposite means decreasing function. When we say a function is decreasing, a function fx is said to be decreasing in AB if x1 less than x2. Two members from open interval we have taken, x1, x2, they are members of open interval AB. But when you put these numbers in the statement of fx, you will see the opposite results. That is, f at x1 gives greater than or equal to answer than f at x2. In that case, we say it is decreasing. Now, there is another method in the form of derivatives. That is, fx is said to be decreasing in AB if for all x belongs to open interval, derivative gives answer less than 0, means answer will be negative for the derivative for all the points in this open interval. Now there are two additional names. They are, if they say function is strictness is there, means strictly increasing, then the whole statement will remain the same, but there will not be any chance of equality. There will not be any equality in this given result. We say function is strictly increasing if x1 less than x2 implies f at x1 less than only f at x2. Similarly, you can say, okay, this one is useful. For strictly increasing, we can use the same result of derivative because there is no equality. It is greater than only. So it is strictly following the result that our derivative is greater than 0. Now if they say strictly decreasing, then For decreasing also there will not be any equality. Your fx1 will be greater than fx2. And derivatives you can use in the same way. This method for finding the strictly decreasing function, you can use the same derivatives form also. If derivative less than 0, here also there is no equality, so it is strictly following the result. So it is for decreasing, first derivative less than 0. So there are few results which we have to remember for exercise 6.2. I hope you will remember all these. Now we are going to start exercise 6.2. Now I am going to start question number 1 of 6.2. It is given like this. Show that the function given by fx equal to 3x plus 17 is increasing on r. R means real numbers. So real number line, remember real number line is between minus infinity and plus infinity. But there is no particular interval mentioned, full real number line given to you. Now we have to start its calculation. Remember students, one thing I want to make very clear here, that is, if you say a function is increasing or if you say a function is strictly increasing, strictly is following more properties. Means strictly increasing function can be said as increasing also. But increasing function we can't say is strictly increasing, because in strictly increasing there will be directly inequality, but there may be equality in increasing only. So remember it. So we have to use two methods here. I want to make both the methods clear. After that we will solve with one method only. So show that the function given by this. So given we have fx equal to 3x plus 17. First method was method number 1. In this method we choose two numbers. Let x1, x2, x1, x2, two members of this real number line x1, x2 be any two members, or you can say points in R. R means real numbers. Now x1 less than x2 we choose, we marked there earlier, we choose x1 less than x2. Now try to form statement of the function, because you want to prove fx1 also less than fx2 because it is increasing. So here you have x1 in place of x. I can multiply both the sides by 3. There will not be any change in this inequality. I will have 3x1 less than 3x2. And if I add 17 in both sides, I am going to give equal increment. There will not be any change in this form or in this symbol. After that, what is this? It is same as if we replace x by x1 in the statement. So we can say it is fx1, and less than, if we replace x by x2, you will have this expression. So it is fx2. So it says therefore fx is a strictly increasing function on R. If it is strictly increasing, we can say therefore fx is increasing on R. So if it is increasing, strictly increasing, we can say it is increasing on R. Now method number 2. Method 2 is very simple. In method number 2, we will write derivative f dash x. What is derivative of this? Its derivative is only 3 into 1. Derivative of x is 1 plus of constant 0, which is 3. Any point you can use in place of x, your answer will remain 3, which is greater than 0 for all x belongs to real number line. So if it is greater than 0, according to this, therefore fx is a increasing function on R. I think this method is more suitable to use. A simple work which you can easily mark and give your answers in direct way. So this was question number 1. Now see what is given in question number 2 of exercise 6.2. Here is one similar question to question number 1, which is question number 2. Show that the function given by fx equal to e raised to power 2x is an increasing function or is increasing on R. So solution in the same way, but I will prefer method number 2, which we discussed with derivatives. So given we have fx equal to e raised to power 2x. If I write its derivative, what is derivative of this? Derivative of e raised to power 2x will remain e raised to power 2x along with derivative of its power, which is 2x, or its derivative is 2. So I will write directly derivative, it is 2 into e raised to power 2x. You choose any number as power of e from real number line, means from minus infinity to infinity. For example, if I am choosing minus 1, you will think for negative numbers it may give negative answer. See, if I choose minus 1 and I will replace here 2 into e raised to power 2 into minus 1, it will give 2 into e raised to power minus 2, which can be written as 2 over e raised to power 2. Again a positive value. So this expression will remain greater than 0 always for all x belong to real numbers. And if your derivative is greater than 0, we will say therefore fx is increasing function on real numbers. This was question number 2. See what is given next in question number 3. Question number 3 is, this is question number 3. It is like this. Show that the function given by fx equal to sin x is, first point, strictly increasing in 0 to pi over 2. Second one, B point, is strictly decreasing in pi over 2 to pi. And third one, C, is neither increasing nor decreasing in 0 to pi. So very first thing, we will start calculation in the same way. What is given to us? We are given with fx equal to sin x. And write its derivative. What is derivative of sin x? Cos x. So wholly whatever we write, that is dependent on this answer of derivative, which is cos x. Here you have to remember about cos curve. If you know, then good, otherwise try to remember cos curve. This is cos curve. Cos starts at 0 degree from 1 and at 90 degree its value becomes 0. So from 0 to pi over 2, its value will remain positive in this part. Then it will start decreasing in this side, and when you give increment of pi over 2 to this, then at pi, from pi over 2 to pi, it will remain negative. This is cos curve. So cos x. For cos x it is the curve. So we have very first part, part A. I want to check from 0 to 90, it is strictly increasing. It is quite clear from this. For any number between 0 and 90 degree, your answer of cos x will remain positive. So we can say it is strictly increasing, the simplest work. Similarly, part B, we want to say it is strictly decreasing from 90 to 180. Clearly from this 90 to 180's gap, cos will show negative answer because its value at pi is minus 1. So this one is the second part. Third, if it show two kinds of results, for some part it is increasing, for some part it is decreasing, it is not showing only one type of result. It is showing two kinds of results in the gap 0 to pi, so that it will not be only increasing or decreasing. So we will say neither increasing nor decreasing in 0 to pi. So let's write its answer. So we will write here now f dash x, which is cos x, always greater than 0 for all x belongs to this open interval 0 to pi over 2. Therefore fx is increasing in 0 to pi over 2 open interval. Remember, 0 and pi over 2, they are not included because this is an open interval. B part, f dash x, which is cos x, less than 0 for all x belongs to 90 to 180. So therefore fx is decreasing in 90 to 180. Now the third, because fx is increasing in 0 to pi over 2 and decreasing in pi over 2 to pi, hence in the end we can say therefore, so hence fx is neither, so it is not showing one kind of result, neither increasing nor decreasing in total interval 0 to pi. So this was question number 3. Very simple, based on only cos curve. Try to remember and there will not be any difficulty. This was third. We will start now question number 4. Students, question number 4 is given like this. Find the intervals in which the function f given by fx equal to 2x square minus 3x is increasing in a part, b part is decreasing. So let's start its calculation. Little bit new work is given. So this new work you have to remember. So first one we will write given, what is given, fx equal to 2x square minus 3x. When you write derivative, derivative will be 4x minus 3. Now students, to find intervals, very first thing you have to remember here, that is you have to write derivative equal to 0. So put derivative, now derivative equal to 0. So what is derivative? It implies 4x minus 3 equal to 0 or 4x equal to 3, lastly x equal to 3 over 4. So we have this, there is no particular type of interval given. So if there is no interval given, that means you have interval of real numbers, and that is between minus infinity to plus infinity. You have a point x which lies on this number line. Suppose it is here. This 3 over 4 is the breaking point of this interval. It will divide this whole interval into two disjoint intervals. Don't consider this 3.3 over 4 in between these intervals. It is only point of breaking the interval in two parts. So first will be minus infinity to 3 over 4. Second will be from 3 over 4 to plus infinity. So we will check where it is increasing and where it is decreasing. So very first thing you have to check answer. Therefore derivative of this, which is 4x minus 3. This derivative for very first interval, which is from minus infinity to 3 over 4. What kind of answer it will show? What kind of answer will be there? It is up to 3 over 4. You can check any point, for any point, this calculation. You know, up to 3 over 4, there will be 0 also in this side. Try to check it for 0. Choose any suitable point and solve it separately or roughly and check what kind of answer it will show. See, if I choose 0, if I use 0 here, 0 into 4, 0 minus 3 will give negative answer. Very easy to check. So we can say its answer, derivative's answer will remain less than 0 for all x belongs to this open interval minus infinity to 3 over 4. Now for the other interval which starts from 3 over 4 and go towards positive infinity, this derivative, what about derivative? 4x minus 3. Choose any point. After 3 over 4 there will be 2 also. You can choose 2, and for 2 if we solve, 4 into 2 8, 8 minus 3 5, 5 which is greater than 0 for all x belongs to 3 over 4 to infinity. Very simple to check. So what we observed, for this interval it is decreasing, for this one it is increasing. So we will write, yes, what will you write? Therefore, for a part we can say, because f dash x, which is less than 0, for which interval? Minus infinity to, this is for part B, we will consider for part A, which is increasing. So f dash x came greater than 0 in this. For interval, what is the interval? 3 over 4 to infinity. Therefore, fx is increasing. Increasing where? In 3 over 4 to infinity. Now b part dependent on this, because f dash x came less than 0 for interval minus infinity to 3 over 4. Therefore, fx is decreasing in which interval? Minus infinity to 3 over 4. So it is a required answer of question number 4. See what is next given in question number 5 after this. Question number 5 is also almost similar to question number 4. Find the intervals in which the function f given by fx equal to 2x cube minus 3x square minus 36x plus 7. First part increasing and second is decreasing. The main thing is you have to find intervals. So firstly write given. What is given to us? Given is fx equal to 2x cube minus 3x square minus 36x plus 7. As we write, always write the derivative. First derivative, it will give 6x square minus 6x, and here it will be minus 36, derivative of constant value 0. So we are having this kind of calculation. We can take 6 out also. It will be x square minus x minus 6. Now we put derivative equal to 0 to find interval. So write derivative equal to 0. It implies 6 times x square minus x minus 6 equal to 0, or 6 we can shift below 0, it will be 0. X square minus x minus 6 equal to 0. Try to factorize if possible. Its factors are minus 3x plus 2x minus 6 equal to 0. This you should know, it is splitting the middle term method. Now it will give, from first two we have x common, x minus 3 left. From last two, 2 common, x minus 3 left. Same factor we will take out, x minus 3 out, x plus 2 left, equal to 0. Now, one by one put them equal to 0 because their product is 0. Product of two factors 0, either first factor 0 or the second one equal to 0. So x minus 1, x minus 3 equal to 0 or x plus 2 equal to 0. They implies we will have two answers of x. x3 or minus 2. Just imagine if we have a number line, there is no particular type of numbers given, so we have to consider real number line. If I mark these 2 points, 3 is suppose here, negative 2 in this side, then it will divide our whole interval into 3 disjoint intervals. First one from minus infinity to minus 2, second from minus 2 to 3, third is from 3 to infinity. So we have to check our answers for these 3 intervals. Then in that we will declare where our function is increasing and where our function is decreasing. But where we put these intervals, try to remember we check answer of derivative for these intervals. Now what is derivative? Derivative is given like this here. Its answer is here. Its derivative's value is given here also. So I will try to solve it again. So what is derivative? Now derivative f dash x, it is 6 times x square minus x minus 6, and after solving this you are having these factors x minus 3 into x plus 2. This you have to remember. Now we will check our answer of derivative for these intervals one by one. So very first for minus infinity to minus 2, f dash x, which is 6x minus 3x plus 2. Students, remember I am telling you an easy way to mark answers in papers. So 6 always positive. What about this x minus 3? Your numbers are from minus infinity to minus 2. Choose any negative number. For example, if I am choosing minus 3, that is in this interval, minus 3 will give minus 6, which is negative. Minus 3 plus 2. Minus 3 plus 2 will give minus 1, which is again negative. Negative into negative will give positive. So our overall answer will be positive, which we can say is greater than 0. Now, you have to remember only in that we will declare where it is increasing or decreasing. This is for increasing because derivative is greater than 0. Now for the second interval, for minus 2 to 3, derivative is 6 times x minus 3 into x plus 2. What about this? What about this value? So, what about its value for minus 2 to 3? Choose any positive number, like if I am choosing 0 only. 0 lies in this interval. 6 times 0 minus 3 will give negative answer, and 0 plus 2 will give positive answer. So negative into positive, negative, overall answer is negative, which is less than 0. This is for decreasing. Now the third interval is from 3 to infinity. So for 3 to infinity, derivative, which is 6 times x minus 3 into x plus 2. Choose any positive number, like if I am choosing 4. 6 into 4 minus 3 will give positive answer, 4 plus 2 will give positive answer. So overall answer will remain positive, which is greater than 0. For these two intervals we have greater than 0 answer, that means function is increasing. And for this interval we have less than 0, means function is decreasing. Now time is to give our answer. So we will declare our answer in the end. First part, because f dash x is greater than 0 in, what are the intervals? In minus infinity to minus 2, and second interval is 3 to infinity. Therefore fx is increasing in these two intervals, minus infinity to minus 2 and 3 to infinity. Now part B for decreasing, because f dash x came less than 0 in which interval? Minus 2 to 3. Therefore fx is decreasing in minus 2 to. So this was answer of question number 5 explained in easy way. I hope you subscribe the channel and press the bell icon. If you have any query, you can contact me and you can write in the comment box. So try to watch all the videos till end. Thanks for watching again. Bye bye.